In this video, we are going to describe about the various components fitted in the fuel oil service system of main engine and their functions. The main engine fuel oil service system of the main engine ensures that the required fuel oil is supplied to the main engine from either the fuel oil service tank or a diesel oil service tank. Main engine fuel oil service system consists of a low sulfur fuel oil service tank, ultra low sulfur fuel oil service tank, heavy fuel oil settling tank, and diesel oil tanks. A quick closing valve, a changeover valve, fuel oil supply pump, a flow meter, fuel oil circulating pumps, fuel oil heaters, viscosity, auto backflush filter, a pressure regulating valve, a mixing tank, camshaft operated fuel pump, fuel injector, a temperature control valve, a pressure and temperature indicating and transmitting instruments, diesel oil service tank. In the system, 2 service tanks, one for low sulfur heavy fuel oil and another for ultra low sulfur heavy fuel oil, 1 settling tank for heavy fuel oil and 1 service tank for diesel oil are shown. Even though a provision is given for the main engine to consume from any of these 4 tanks, most of the time the main engine fuel oil service system is lined up from one of the heavy fuel oil service tanks. When the ship is in emission control areas, either ultra low sulfur heavy fuel oil or diesel oil, which is having sulfur content less than 0.1% mass by mass, is used. When the ship is outside emission control areas, low sulfur heavy fuel oil, which is having sulfur content less than 0.5% mass by mass, is used. Each of the service outlet pipeline from the 4 tanks mentioned above are fitted with quick closing valve immediately next to the tank. In case of fire inside the engine room, the fuel oil outlets from these tanks can be stopped by operating the quick closing valves from outside the engine room. The changeover valve shown is used to change over the consumption from heavy fuel oil to diesel oil or vice versa. Fuel oil supply pumps take suction from the tank which is lined up for consumption and build up a pressure of up to 5 kg per square centimeter and supply to main engine fuel oil circulating pump through flow meter. The pumps, 2 in numbers, are of gear type and driven by electric motors. One of these pumps is required to be run for the main engine operation. The pumps are fitted with a compound gauge in the suction side. A pressure gauge in the discharge side. The pumps have isolation valves both in the suction side and the discharge side. The valve in the discharge side is a non-return valve. A pressure regulating valve is fitted parallel to the pumps to maintain a constant pressure in the discharge side of the fuel oil supply pump. The flow meter, which is fitted in the discharge side of main engine fuel oil supply pumps, is used to calculate the fuel oil consumption of main engine. The flow meter reading is logged at noon every day and at all important vessel movement events, such as standby, full away, and finished with engine to calculate the fuel oil consumption of main engine during sea steaming and harbor steaming. Fuel oil circulating pumps take suction from the mixing tank and as well from the oil pumped by fuel oil supply pumps through the flow meter and build up a pressure of up to 9 kg per square centimeter and supply to main engine camshaft driven fuel oil pumps through fuel oil heaters and viscotherm. The pumps, 2 in numbers, are gear type and driven by electric motor. One of these pumps is required to be run always whether the main engine is in running mode or stopped mode. As these pumps keep circulating the hot fuel oil, always through the main engine camshaft driven fuel oil pumps and fuel oil injectors so that the main engine can be started and stopped in heavy fuel oil. The pumps are fitted with a compound gauge in the suction side, a pressure gauge in the discharge side, the pumps have isolation valves both in the suction side and the discharge side. The valve in the discharge side is a non-return valve. The main engine from fuel oil circulating pump enters the main engine fuel oil heaters to raise the temperature to the required level so that the correct viscosity of fuel oil, as recommended by the engine maker, is maintained when it enters the main engine. The heaters are 2 in numbers arranged in parallel with a bypass line. They can be of shell and tube type using steam as the heating media. Viscotherm measures the viscosity of the fuel oil coming out of the main engine fuel oil heaters and maintains it constant at the set value by regulating the valve fitted in the steam inlet to the heater. Auto backflush filter is fitted before the fuel oil enters the main engine and fitted with auto backflushing mechanism, which backflushes the filter elements automatically upon sensing a high differential pressure across the filter by the differential pressure switch. The fuel oil from the auto backflush filter enters the camshaft-driven fuel oil pumps, which increases the pressure to about 1,000 bar in fuel oil high-pressure pipe. Fuel oil high-pressure pipes connect the camshaft-driven fuel oil pumps to the fuel oil injectors. 2 or 3 numbers of fuel oil injectors are fitted surrounding the exhaust valve on the cylinder head. Whenever the pressure in the high-pressure pipes exceed the opening pressure of fuel injectors, the injector nozzles are lifted. The fuel oil is injected in the cylinder in a fine atomized state. As the fuel consumption of the engine varies with the load, to maintain a constant pressure of fuel oil at the inlet to the engine-driven fuel oil pump. A pressure regulating valve is fitted. The pressure regulating valve bypasses the excess fuel oil to the suction side of the circulating pump through the mixing tank. The excess return fuel oil from the main engine and the fuel oil relieved from the fuel oil pressure regulating valve enters the mixing tank, and the fuel oil recirculating pump takes suction from the mixing tank and from the discharge pipeline of the fuel oil supply pumps. Now let us see the various measuring instruments fitted in the system. A compound gauge at the suction side of the fuel oil supply pump, a pressure gauge at the discharge side of the fuel oil supply pump, a pressure switch at the discharge side of the fuel oil supply pump to give low fuel oil supply pump discharge pressure alarm and to start the standby pump automatically. A compound gauge at the suction side of the fuel oil circulating pump, a pressure gauge at the discharge side of the fuel oil circulating pump, a pressure switch at the discharge side of the fuel oil circulating pump to give low fuel oil circulating pump discharge pressure alarm and to start the standby pump automatically, a thermometer at the fuel oil inlet to the heater, a thermometer at the fuel oil outlet from the heater, a viscotherm to measure the viscosity of the fuel oil coming out of the heater and take corrective action of automatically adjusting the steam flow to heater to maintain the fuel oil viscosity at entry to the engine at the recommended value of the engine maker. A pressure gauge at the inlet to the auto backflush filter. A pressure gauge at the outlet of the auto backflush filter. A differential pressure switch, which measures the pressure difference across the auto backflush filter to initiate the backflush cycle. A pressure switch fitted at the fuel oil inlet manifold to the camshaft-driven fuel pump to give alarm at low fuel oil pressure. A pressure switch fitted at the fuel oil inlet manifold to the camshaft-driven fuel pump to shut down main engine at extra low fuel oil pressure. A pressure gauge fitted at the fuel oil inlet manifold to the camshaft-driven fuel pump. Hope this video helped you in understanding the fuel oil service system of main engine. Thank you for watching, and don't forget to subscribe to our channel for more educational content.